That streaming that cannot be done. Okay. That now chats.
You can see in your phone.
But call may come, no? Calls may come, no? For me. Yeah, it's better if it is done. 1 minute it may take. You get it ready and live. You turn this side. Hello, good morning, everyone. Hope you're all switched on. I'm G.R. Maskeri, PGT Chemistry of JNV Dharwad, presenting before you the organic chemistry part of class 12th. And today I have chosen organic chemistry because many students are also telling about organic chemistry part which need more strengthening. Probably in half-yearly examination, the situation may not be good. And it needs some strategy. Of course, learning is an information stage. For confirmation, there needs some strategy. And remembering is a task in chemistry. That too, in particularly organic chemistry, remembering the whole lot of syllabus is a very typical thing to be adopted. And this academic support is organized by NVS Hyderabad region to facilitate all the students to acquire more and more knowledge about the topics. Hope I'm audible and clear, right? So we will take up organic chemistry, right? And in this organic chemistry, there are 4 chapters. And let us do all the 4 chapters together. This is what the mixing up of the content. Mixing up of the content is essential because in the question paper, when we see, this won't come as chapter wise. Questions won't come chapter wise. You need to organize yourself to attempt that question. Okay, so what shall we do is we will go concept wise this thing. What are the concepts which are very important in this organic chemistry? First one is naming, IUPAC naming of organic, IUPAC naming, right? Okay, in IUPAC naming, there may be question as an objective type questions, or indirect way also they may ask in the word questions that are appearing in the board examination. They ask you to write the name of IUPAC name of A, B, C, etc. So this is one topic. In this way, we need to go for another one, distinguishing test. Distinguishing test means 2 compounds will be given and you have to suppose to remember a reagent which distinguishes both the compounds, right? We'll look into that. Then named reactions. So there are several named reactions, Woods reactions, Sandmeyer's reactions, and in aldehydes, ketones, there are several named reactions. Okay, how to remember that? It will be a task. We'll give some tips how we can able to remember that and comfortably write in the examination, right? Okay. Okay, this is mechanism of the reaction. Another thing is mechanism of the reactions. Of course, you need not remember or mechanism of all the reactions, particularly a few reactions of which mechanisms will be asked. Let us see which are those reactions, right? And reasoning questions. Reasoning questions can be asked in assertions and reasoning type, and also directly also they may ask give the reason to in that way. So we'll see that also. And ABC type of questions, ABC type of questions, which is latest trend in the CBSE examinations, and we will see that. And also conversions. Conversion is ultimate thing that from one compound to another compound we have to convert by using several reagents. It may be happening, it may done in 2 steps or in several steps. We shall see how we can do that. Right. First, coming to the IUPAC names. Right. So this, you know about these things well, but still let us know more clearly about it. Any organic compound will be having 3 different phases of naming. Word root depends upon the number of carbon atoms, and there are prefixes which is to be added before the word root, and also suffixes, right? Suffixes are COOH, that is oic acid. If the carboxylic acid is there, we have to suffix oic acid. You know about it. Therefore, let me go ahead. Amides and esters. Amides and esters. These are the next two on priority basis. All these are written on priority basis. I mean, where is the you can come. Just a minute. There is a okay, yeah. 1 minute. Oh, yeah. That is this one, huh? Okay. Okay, fine. Okay, this is these are on the priority basis. Remember, priority basis of this will come only if there are 2 functional groups in one particular compound given. All right. So carboxylic acid comes first when there is alcohol group. Alcohol and carboxylic acid, both the functional groups are being given. Carboxylic acid is the prior group. In that way, we have to consider. Therefore, these are written on priority basis. First, carboxylic acid, then amide, then ester, then cyanides or nitriles, aldehydes, ketones, alcohols, and amines. So this is the way that priority is fixed. And prefixes are whenever an halogen is there, always it is a prefix, and nitro group is there or alkoxy group is there, it is always to be added in prefixes. So these are the key things to be remembered. Or alkyl groups also will be in the prefixes that we have to add. Therefore, given an organic compound, we have to do naming by considering all this. So we will take up naming of these things, right? Come on. It may look easy. If I suggest you, if you are having, you are entered in Zoom meeting, you can open up the message and you can name that, right? So it can be made interactive if you take up in the Zoom meeting. Otherwise, you can keep some rough notebook or the notebook that you have and try each and every question that is being given, right? So this is the compound, maybe looking easy for many of you. And how to name that? I will wait for your messages. Okay. Okay. This is 2-methyl 1-bromopropane. How it is identified? See, this is the first carbon atom. This is the second carbon atom. This is the third carbon atom, because the one carbon which is having functional group is the first carbon atom. 1-bromo. Second, there is a methyl, right? And there are 3 carbon atoms. Therefore, this is prop. Prop is the word root. Ane. Ane, because it is only containing single bonds. Okay, these are the preliminary things that you know about it, right? So 2-methyl, second carbon is having methyl, and 1-bromopropane, right? Now, how to name this? For every question, I will give pause. You can make use of the pause, and you can give the message, or you can write down on a paper and check when the answer is being told. Yes, right. Okay, I will give you clues, right? So this is the carbon atom 1, 2, 3, okay, 3. And remember, sometimes they may give like this. This means that for this carbon atom, there is 2 CH3. Now, this carbon atom is having 2 CH3, right? And so that carbon valency you can tally. Carbon has got 4 valency or 4 bonds. 1, 2, 3, 4 bonds. And 1 CH3 will be here. That is 4th carbon atom. So word root is having 4 carbon atoms, right? That is butane, right? It is butane. And whether to be started from here or here may be the question, right? If it is started from here, it is 2,2 dimethyl, right? It will come like that. Or if you start from here, it will be 1-chloro and 3,3 dimethyl, right? So now this is 1-chloro 3,3 dimethyl butane. 1-chloro 3,3 dimethyl butane. The two possibilities. So you have to choose the set of locants which is sum is less. For that, this could be the answer. Going to the third one. Now look at this. This is C double bond O, ketonic group, right? And this is not the branch. Always, if the last carbon atom is written like this, don't consider this as a branch. So this is the first carbon atom. This is the first carbon atom. This second carbon atom, third one, fourth one, fifth one. Okay. Now, this is the one longest carbon-carbon chain possible. Then ketonic group is prior to alcohol group, right? This is the second thing, information that you must make use of. So second, third, fourth carbon atom is hydroxy group. So whenever the alcohol is there, prefix for this is hydroxy. Therefore, what is the name? What is the name of this? So this is 4-hydroxy butane 2-one. 4-hydroxy 1, 2, 3, 4. 4-hydroxy butane 3-one. Okay. So this is the name of it. Okay. Now coming to this, the one which is containing benzene ring. So this is phenol and 2-methyl phenol. 2-methyl phenol. Easy? Feeling easy? Next compound. So Zoom link is not being given now. Okay. Now this is the first carbon atom, second, third, fourth, fifth, and sixth. So basically it is hexanal, but it is not ene. There is ene. In the alkyl group, there is alkene. Okay, it is the double bond is there. So there is third carbon atom. Okay, 3 and 4th both are having double bond, but the one which is having less number you have to choose there, right? So this is okay. Hex 3 in 1 all. Hex 3 in 1 all. Wherever there is in, prefix 3 is to be given, right? Okay, fine. Right. I think this is simple. I think no need of much trial from you. This is benzaldehyde or benzene carbaldehyde is the better one because benzene and CHO group is there if attached there. So here it is the bond. So benzene carbaldehyde, right? Or benzaldehyde. Okay. Now the thing is this is an ester. COO is there, it is an ester. Okay. Now this can be written in a proper way so that you can understand what is to be taken. CH3, CO, this is having double bond, O, CH2, CH3. This is an ester, right? And in this, the one which is attaches to O, oxygen, singly bonded oxygen, this is alkyl group from alcohol. This is alkyl group from alcohol. So that is to be named first. So esters are named alkyl alkanoate. Alkyl alkanoate. Therefore, it is ethyl ethanoate. It is ethyl ethanoate. That is the way. Okay. Ethyl ethanoate, right? Okay. Now coming to this, amides. These are amides, right? So how to name the amide? Amide is alkanamide. That is the way. So remember for every organic compound in this way. Alkanamide, if CONH2 is there, and simply if NH2 is there, that is alkanamine. This is alkanamine, right? So how many carbon atoms are there? 3 carbon atoms, including the one which is having C double bond O, right? This C double bond O. Therefore, this is propanamide. Propanamide is the one. Okay. Propanamide, right? Propanamide is the name of it. Now, this is in bond line formula. Each term, okay, is a carbon atom. So 1, 2, 3 carbon atoms are there. Therefore, what should be the name of it? This should be propanamine. This is propanamine, propanamide, right? Okay. Okay. Right. Now, this is CH3OC2H5. CH3OC2H5. So, better to understand if it is written in this way, you may feel more comfortable. A smaller numbered carbon atoms of alkyl group is to be taken as is a prefix. I mean, one carbon atom containing alkyl group, that is methyl. Methoxy, this is methoxy, that is considered along with it, methoxy ethane. This is methoxy ethane, not ethoxy methane. It is not ethoxy methane, this is methoxy ethane. Okay. Then alkene should be have more number of more number of carbon atoms. Now, what about this? This you try for a while. Okay, remember, this is the prior functional group, therefore first carbon atom. This is the second carbon atom, right? If functional group is in the side chain, it is a derivative of the side chain. It is a derivative of that compound. Therefore, this is ethanoic acid. Basically, it is ethanoic acid. And this is considered as prefix. Prefixes means it is branches. Branches are named as prefixes. So whenever benzene ring is there, we take it as phenyl. So what is the name of this? 2-phenyl ethanoic acid. It is 2-phenyl ethanoic acid. Right. Now coming to the one. Okay. Twelfth one. Look at this 12th one. Along with CHO group, there is OH also. Which is prior, OH or CHO? Always carbon containing functional groups are at prior. Therefore, it is 2-hydroxy. This is the first carbon atom of the benzene ring. Second carbon atom of the benzene ring. 2-hydroxy benzaldehyde or benzene carbaldehyde. 2-hydroxy benzaldehyde. 2-hydroxy benzaldehyde. Right. What about this 13th one? So this is the carbon. Here is a carbon, and this carbon is having double bond. Carbon having double bond and having 2 alkyl groups. This is CH2 and CH2, alkyl groups only, carbon-carbon bond. Therefore, it is a ketone. Basically, it is ketone. So what should be the name of this? This is cyclopentanone. Cyclopentanone, because 5 carbon atoms are there. Cyclopentanone, on. Right. Now, so this is in the side chain, therefore is derivative of side chain. CO, if it is written like this, nothing but C double bond O. It may be considered like this, C double bond O, right? Okay. So this is CH3CO and a benzene ring. So this is the first carbon atom. This should be considered as first carbon atom. Okay. So this is second carbon atom. So 1-phenyl ethanone. 1-phenyl ethanone. Okay, this is commonly called as acetophenone. So many a time we write this as acetophenone. What is that? Acetophenone. This is the common name. Here, this is phenyl ethanone. Phenyl ethanone. 1-phenyl ethanone. Sometime it may be left, or 1-phenyl ethanone, right? So can you identify which type of amine is this? This is secondary amine, right? Secondary amine. So basically this is CH3NH2. This is primary amine. One of the hydrogen is replaced by another alkyl group. There are 2 alkyl groups. There are secondary amines. These secondary amines. How secondary amines are named? N-alkyl alkanamine. This is the way of naming. N-alkyl for nitrogen, capital N. Methyl group is there. N-methyl methanamine. Simple. They are all simple one you have chosen. Okay. Now, the another way also you must know. If aniline is asked, you must can you able to draw the structure of it? Write the structural formula of aniline. Aniline. Okay, aniline is considered as IUPAC name. Many a time we are using. Okay, there must be a benzene ring. So recall that. And there must be NH2 group, right? NH2. C6H5 NH2. This is aniline. Okay. And there is another compound called anisole. Confusing. Okay. Anisole is C6H5OCH3. Methoxybenzene. Methoxybenzene is anisole. It is an ether. That is an amine. Right? So this is aniline, anisole. Try to bring them together and recall so that you will not get confused in the further. Now, the eraser is not there. Okay. So you can do that. Right. So 2-hydroxypropanoic acid. 2-hydroxypropanoic acid. Try for a while. 2-hydroxypropanoic acid. So always choose the word root. Always while writing the names of this, choose the word root. So this is having 3 carbon atoms. Yes. Prop. Prop means 3 carbon atoms. Then fill the things. It is propanoic acid, including this carbon atom. Therefore, it should be COOH, right? Propanoic acid. 2-hydroxy. That means second carbon atom. This is always prior. First one and second one. 2-hydroxypropanoic acid. And simply, you have to fill the other things. CH3, CHOH, COOH. Okay. This carbon atom, CH3. And this is CH. Here H is to be included, right? Ethyl magnesium bromide. Ethyl magnesium bromide. There is a name for such kind of compounds. What is that special name? Grignard reagent, right? Grignard reagent. Ethyl magnesium bromide. This is CH3. Okay, of course. You can get it. CH3, CH2, MgBr. Ethyl group. Or you may write C2H5, MgBr. Okay, right. Right. Now 2,4-dinitrophenol. 2,4-dinitrophenol, right? It is not hydrazine, 2,4-dinitrophenol, right? So here the clue is being there. 2,4-dinitro. Where to be chosen as 2 and 4? It is basically phenol. Therefore, OH should come for one of the carbon atom. Comparing that carbon of the benzene ring, you should arrange other things, right? Okay, right. So this is 2,4. This is first carbon atom. This is second, third, and 4. 2,4-dinitrophenol, right? This is the way, right? Methyl ethanoate. You take some time. Methyl ethanoate. Right. See, ethanoate. Methyl is, I told you about the naming of ester. It is an ester. Ethanoate. Methyl group should be the alkyl group, which is to be spelled, which is attached to oxygen. Ethanoate. One carbon atom is already there, and then another. CH3, COO, CH3. There is a chance of doing mistake. You might have written C2H5 or CH3, CH2 here. That's the mistake. You may avoid it. Right. CH3, COO, CH3. Right. Okay. So for NCERT textbook, some questions I have chosen so that you may, which are confusing or so. This is from the first chapter. Give the IUPAC names of the following, right? So all questions are taken together just to tell you that. So how confusing it is. Okay, some methyl group is here, and here the methyl group is there, and this methyl group is taken out, and so on. So try all such questions, right? So now coming to this, this particular question. How to name this? Now, this is the first carbon atom, or this is the first carbon atom, which is to be given importance. So here double bond is there. Remember that there are carbon atoms here. All terminals, there is carbon atom, right? Okay. Now, this is the first carbon atom. This is the second one, third one, fourth one, fifth one. Because ene is more important than the halogen functional group. If halogen is there and alkene is there, alkene is to be given importance. Right. Therefore, this is the second carbon atom, because second carbon atom will get ene if we start from here, or if you start from here, 1, 2, 3. Therefore, the choice is to be given such a way that the carbon atom containing double bond should have least number. Now, coin the name. This is 4-bromo. 4-bromo, pent, word root, pent to ene. Okay. Okay, I have not written that. So 2-bromo. Sorry. Yeah. 2-bromo. 2-bromo, pent to ene. Sorry, 4-bromo. 4-bromo. 4-bromo, pent to ene. Okay. Changing option. Okay. Now coming to this. How to take up the carbon atoms. This is the first carbon atom. This is the first carbon atom. Why this is the first carbon atom? Because alkene should be again the same way you have to name this. Now what could be the name of this? So the second carbon atom, there is a methyl group. This is the longest carbon-carbon chain possible. So the longest carbon-carbon chain is this one, right? So this is 2-methyl. Alkyl group should be a prefix, 2-methyl. Okay. So this is bute, 4 carbon atom, bute. Okay. Sorry, this is again 2-methyl. Before that, 3-chloro also we have to add. 3-chloro. 3-chloro. Sorry, through bromo, not chloro, bromo. 3-bromo, 2-methyl, butane, bute 1-ene, bute 1-ene, right? So this is B comes first in alphabetically, then M. Therefore, bromo is to be chosen first. Whatever may be the locants, this is maybe more or this may be less, that doesn't matter. This should be alphabetical, right? 4-bromo is to be written first, right? And bute 1-ene. The ene, ene, on, all these are primary suffixes. Before, if the functional group is there, that is to be taken before that. Okay, that is the point to be remembered. Now we will take up this. Yes. Responses I'm getting there. Many students are writing responses, but only YouTube channel responses are there here, not Zoom meeting responses. Okay. Zoom meet responses. Okay. Okay, anyway, right. Now, so look at this. This is a typical question. This is a typical question. So if you start from numbering here, 1, 2, 3, 4, second carbon atom is getting alkene because there is no CH3 here, right? Now, if you start from here, 1, 2, 3, 4, right? So second carbon atom only is being alkene. Carbon atom is having alkene. Therefore, whenever the possibility is there, you have to take, okay, you have to take in such a way that this also gets a least number. Therefore, this way of naming is the more right way. Okay, 1 bromo, but, 1, 2, 3, 4, but to ene. 1 bromo, but to ene. 1 bromo, but to ene. Okay, so but because of 4 carbon atom, ene because of second carbon atom is containing ene, right? So every problem here is typical. This is carbon, this is carbon, this is carbon. You can mark it and then you can try. So now this is the first carbon atom. This becomes the first carbon atom. Okay. Now this is 3 bromo, 2 methyl, 3 bromo, 2 methyl, but 1 ene. This is 3 bromo, 2 methyl, prop, not but, propene. This is propene. 1, 2, 3 carbon atom in the longest carbon-carbon chain, right? Okay. Right. Ene is to be given importance. Then that bromohalogen atom which is present there. Okay. Hope you have understood. So in the examinations, okay, in the examinations, how the questions are asked. Okay, in a typical way they may ask, and we will take up the question from sample paper that is being sample paper which is there. Now, what is the IUPAC name of ketone A? What is the IUPAC name of ketone A, which undergoes iodoform reaction to give CH3CH double bond CCH3COONA and yellow precipitate of CHI3. Okay. So this way they may ask the question. Now, this is the one which is the compound, and these are the two compounds which are obtained. That means here the product is being given. Analyze it properly. How to attack the question is important. CH, C, CH3, this is branch, right? COONA plus CHI3, iodoform. An iodoform test, we get CHI3, right? And sodium salt of carboxylic acid. These are the two things we are getting, right? Now compare with the reaction, actual reaction, or the generalized form of the reaction. If there is, okay, a compound like this, right? We'll take like this. If a compound is CH3, C double bond OR, such compounds undergo iodoform reaction. Such compounds undergo iodoform reaction. Two ketones undergo iodoform reactions, or two alcohols. That means second carbon atom should have this carbon oxygen bond, right? This bond should be there. These are the compounds which undergo iodoform reaction. Now, what is the first stage that happens is reaction with I2 gives Ci3, all this hydrogen of the carbon next to C double bond O get iodine. All these are replaced by iodine. Ci3, C double bond OR. Then the next stage, NaOH, when you add NaOH, it will form CHI3. You can take it like that, CHI3, which is iodoform, and RCOO Na plus RCOO Na. RCOO Na. These are the two things which are formed, right? So this RCOO Na is being here, RCOO Na and CHI3. Now, how they have come from here? So this is the alkyl group of C double bond O, right? Alkyl group of C double bond O. Okay. Now you can coin the things. This is CHI3 is from CH3. CHI3 from CH3, and it should be from this C double bond O. It should be attached to C double bond O. This is C double bond O. And next to that, there is a C with CH3. And all other things you can repeat. CH3. Okay. COONA, wherever COONA is there, there must be this CO is from ketone. That CH3 is giving CHI3 at the end. CH3 is giving CHI3 and RCO. This is from sodium salt. Now, this is the compound from which you have to name this compound. You have to name this compound. Okay. Right. So this is first carbon atom. This is second carbon atom, third carbon atom, fourth and fifth. 5 carbon atoms. And second carbon atom is having C double bond O. That is prior functional group. And ene is there. And methyl group is there as a branch for the third carbon atom. Okay, so you must know about all these iodoform test, and then you have to choose the ketone and then name it, right? So it is an objective type question, but these are the things that you need to do before attempting the question, right? So this is 3-methyl, pent, 3-ene, 2-one. Okay. So which is the answer? Okay. Which is the answer? 3-methyl, pent, 3-ene, 2-one. First one is the answer, and the other 4 are. So the 4 answers are given. It will be little simple. It becomes little simple because 3-methyl pent 4-one can be easily rejected because 4-one, 3-methyl is not a possibility. It's given priority. Okay. So elimination of some answers can be done. Okay. And there may lies that you have to identify which is the correct one by taking the question and write that this rough work is needed, right? For attempting an objective type question, rough work is needed, right? Okay. So another question from the sample paper. Hope it is visible. Right. So A and B dilute NaOH will give this compound. Okay. And identify A and B. Identify A and B. So I will write here A plus B giving rise to it. The dilute NaOH will give, there is a benzene ring, right? Okay, benzene ring, CH, double bond, CH, C double bond O, again there is another benzene ring. So what type of reaction is this? So with dilute NaOH, okay, if you get some compound like this, it is an enol or enone. It is an enone. So you have studied in aldol condensation, right? Aldol condensation. Aldehyde and ketones in the presence of a base, dilute NaOH, will undergo a condensation reaction because A and B has condensed. These are the clues, right? A and B undergo a condensation. Okay. So there is a ketonic group remained as it is, and it is they should have given that heating also, NaOH plus heat, because after heating this has been obtained, right? Now which are the compounds? A may be having this skeleton, an aldehyde, okay, C double bond OH, this may be this aldehyde, and the B may be CH3CO C6H5. As you know that the C double bond, the next to this, okay, next to that is alpha carbon. This hydrogen will go here, right? And this carbon get attached to the carbon containing the functional group. And the OH and the H, all these undergo condensation or elimination of water molecule to give this product. Therefore, A is this and B is this, right? You have to name this. This is a benzaldehyde and this is acetophenone. CH3CO with the benzene ring is acetophenone or 1-phenyl ethanone, right? Okay. So again, 4 options are being given. In objective type questions only it is being asked. Okay. So this is, you may not able to see it properly. This is benzaldehyde and acetophenone. C is the option, right? Okay. So this is about the naming of organic compounds, right? Some typical questions of naming can be asked in the CBSE examination, but have the basic knowledge of how the IUPAC name is being given. Okay. So you may have to, with this little trials, you will get to the perfection of this. Okay. Then coming to the distinguishing test. In distinguishing test, 2 compounds will be given. And what you have to remember, what you have to do is you have to choose a reagent. That particular reagent gives a characteristic change with the one of the compounds given and not with the other. Therefore, we have to remember the reagents which give the reaction with a particular kind of functional group, right? Okay. I have made a list of this here. List of these reagents which you have to remember, right? So here, neutral ferric chloride. This is given by only phenols. It is given by only phenols, and violet or purple colored characteristic change you will get. Okay. Neutral ferric chloride reacts with only phenols. It won't react with alcohols, even though the OH group is there. Alcohols won't react with it. So neutral ferric chloride is having this color. Okay, brown colored one will give violet colored phenols. Another reagent, sodium bicarbonate. Sodium bicarbonate is the one which is used for testing the presence of carboxylic acid group, COOH group. If COOH is present, then we can identify by adding sodium bicarbonate. There will be brisk effervescence of carbon dioxide. Carbonates and bicarbonates give carbon dioxide when it reacts with carboxylic acid. Okay, fine. So ionoform test, very important. What type of compounds will give? 2 ketones, 2 alcohols, ethanol, 2 aldehydes and 2 ketones will give. So this is yellow colored PPT, right? Then Tollens test. Tollens test is ammonical silver nitrate. It is given by only aldehydes. Will give silver mirror. Give silver mirror. Now, carbylamine test only for the primary amines that you can have. Carbylamine test, right? And you will give offensive smell. Through the smell, you are identifying. Only primary amines will give this carbylamine test. You have to add chloroform and KOH. Then Lucas test. It is meant for distinguishing primary, secondary, tertiary alcohols. Lucas test. This is anhydrous zinc chloride plus HCl. Anhydrous zinc chloride HCl. Reaction with HCl supported by anhydrous zinc chloride. Hinsberg test. Hinsberg test is meant for distinguishing primary, secondary, and tertiary amines. Okay, there are seven these reactions or 7 reagents you have to remember, so that whatever may be the question asked in the examination, you may able to answer it, right? More comfortably, right? Neutral ferric chloride for phenols. Sodium bicarbonate for carboxylic acid. Iodoform test is iodine in NaOH. Iodine NaOH. For 2 ketones and 2 alcohols, it will give yellow PPT. Tollens reagent, ammonical silver nitrate, will give silver precipitate. Carbylamine test, of course, you can avoid this also because we have got Hinsberg reagent. Okay, so there is Fahelin's test also for the aldehydes and ketones. But adopt one of this. Remember, for the distinguishing test, you can take Tollens test because Tollens test is giving both for aromatic and aliphatic aldehydes, right? Ketones won't give. Okay, there is a 2,4-DNP test. That is another one which will give given by both aldehydes and ketones. If aldehydes and ketones are given with both are giving, and ketone is given with some other compound like alcohol, then you can adopt for 2,4-DNP test also. I will take up the example, but minimize the number of reagents so that you will remember it comfortably. So that 7 reagents you may remember, and do some practice for distinguishing. Okay, we'll see. So name the reagent for distinguishing the compound. So are you ready to take the challenge? How you are remembering? Let us test that. Okay, phenol and methanol. Phenol and methanol. 2 compounds are being given. This is phenol. One is phenol and another is methanol. Okay, so you have to choose that reagent which gives only characteristic change. Okay, so know that phenol is giving that particular change. Phenol. Okay. Phenol is giving this change. Phenol is giving this neutral ferric chloride, FeCl3, neutral ferric chloride. What is the change in color? Brown color to ferric chloride to violet coloration. Okay, fine. So identify this, neutral ferric chloride. Come on. Propane 1-ol, propane 2-ol. Propane 1-ol, propane 2-ol. Propane CH3, CH2, CH2OH. This is propane 1-ol. Another thing is CH3, CHOH, CH3. This is propane 1-ol. This is propane 2-ol. So this is primary alcohol. This is secondary alcohol. So both are having alcohol group. Now, how we can able to distinguish? This is Lucas reagent, right? This is Lucas reagent. Lucas reagent distinguishes primary, secondary, tertiary alcohols, right? And the reagent is anhydrous zinc chloride plus HCl. Now just identify the reagent. I will tell you how to write the reaction and all in the later stage, right? First, identify the reagent which distinguishes these two. Distinguishes. So Lucas reagent will give white turbidity to the secondary alcohols after 5 minutes, but primary alcohols it won't give at room temperature. Primary alcohols won't give Lucas test in room temperature. Therefore, this is the reagent which distinguishes. Propane 2-ol gives white turbidity. Why white turbidity? Because it is converted into propane 2 chlorides. Propane 2 chloride. This is haloalkanes are less soluble than alcohols. Whenever solubility is less, that salt, that compound will appear in the form of a solid. So that is white turbidity, right? That is white turbidity. Therefore, Lucas reagent is being used then. Ethanol, propanol. Ethanol, propanol. Okay. Ethanol. Propanol. Okay, propanol, I told you now. Now, one thing that we are going to see is both are primary alcohols. Both are primary alcohols. Now, Lucas reagent may not help because out of 2 alcohols, both are primary alcohols, then Lucas reagent cannot be used, right? Now, which one can be used? Look at this, CH3, CH2H. If it is written in this way, probably you will get the clue. CH3, CH2OH. Okay, so it is having skeleton of this skeleton, I mean CH3 attached to next to C double bond or CO bond. So this skeleton you have to identify. This is iodoform test is being given by this. 2 alcohols, 2 ketones. 2 alcohols and 2 ketones. If alcohol group is there in the second carbon atom next to methyl group. Next to methyl group, okay. Next to methyl group, if alcohol is there, next to methyl group there is ketonic group is there, then it will give iodoform test. What is iodoform test? What is the reagent that you are using? So iodoform test is NaOH plus I2. It will give CHI3 yellow precipitate, right? Iodoform test, of course. Okay, right. What happened? Okay. Yes. Methanol and methanoic acid. Methanol and methanoic acid. Methanol. Methanol is, sorry, this is CHO. This is methanol, right? Methanol. And methanoic acid is HCOH. Methanol and methanoic acid. So always, whenever aldehyde and carboxylic acid is given, I suggest you to take carboxylic acid, the reagent which distinguishes carboxylic acid, right? So here, carboxylic acid will give brisk effervescence of CO2 with sodium bicarbonate, NaHCO3 test, right? And remember, this is a typical question. If you have wrongly chosen as, Tollens reagent, this is given by even methanoic acid. This is one carboxylic acid which gives Tollens test. Therefore, it is a typical question. You should not choose Tollens reagent for distinguishing because both will give precipitate of silver. And better, whenever the carboxylic acid is there, choose sodium bicarbonate. So HCOH with sodium bicarbonate will give you carbon dioxide, but not aldehyde, right? Therefore, sodium bicarbonate test. Okay. Okay, fine. Now coming to benzaldehyde and acetone. Benzaldehyde and acetone. Benzaldehyde and acetone. Benzaldehyde. So rough paper, you should draw these things quickly. And acetone. Always write the structure of the organic compounds whenever the question is asked. Help you have yourself to go to the next stage of learning. Before that, you should be able to write the structure of this properly. One is aldehyde, another is ketone. You know that aldehyde especially will give Tollens reaction. Tollens reagent test. That is, it gives silver mirror. It will answer silver mirror. Okay. Therefore, this one is Tollens test, right? Tollens test. Now, I hope this is clear and you may do it now faster. Propanol, propanone, propanol, propanone, propanol, propanone. Again, one is aldehyde, another is ketone. Which is the test? Okay. This is Tollens test. Once again, it is a Tollens test. Right. Propanoic acid and propanol. Propanoic acid and propanol. As I told you, which is the reagent that you use? Better reagent that you can use is for carboxylic acid, use sodium bicarbonate test, right? Sodium bicarbonate test. Okay. And Tollens test also we can use, of course. Okay. 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 Right. Okay. Sodium bicarbonate test. Then ethylamine and diethylamine. Ethylamine and diethylamine. Ethylamine, CH3, CH2, NH2. This is ethylamine. Right? Diethylamine. So CH3, CH2 twice NH. Okay, two alkyl groups are there. This is secondary amine, this is primary amine. So there we use Hinsberg reagent. What is Hinsberg reagent? Hinsberg reagent is benzene sulfonyl chloride. Benzene sulfonyl chloride, SO2Cl. Okay. This distinguishes primary, secondary, and tertiary amines. Primary amines will give soluble compound with this Hinsberg reagent. Secondary amines will form insoluble compound with KOH, and the tertiary amines do not react. It doesn't react with it. Therefore, Hinsberg reagent is the one which to be taken care of. So primary, so what you have to do is given two compounds, first try to identify through the structure, is it primary or secondary? Then choose a reagent. First have that particular ability to find the reagent, right? Hinsberg reagent. Phenol and aniline. Once again, phenol and aniline. Phenol will give, phenol gives neutral ferric chloride with neutral ferric chloride, right? Violet coloration. Therefore, you have to choose neutral ferric chloride. Then, lastly, cyclohexanol phenol. Again, choose one of this. This is better. Cyclohexanol will give neutral ferric chloride test. Once again, it is neutral ferric chloride, right? Okay. Now, how to write the test? How to write the test in examinations? Okay. In the examination, if this is being given, first you have to identify the reagent. But to write it in a proper way, you may give equations particular to that. Now, phenol, there is phenol, right? This is phenol and methanol, both compounds, one below the other, you write, and choose the same reagent. Choose the same reagent, that is neutral ferric chloride. Neutral ferric chloride, right? So both reagent is to be written because you are adding the reagent to both the compounds given in separately. Okay, this gives characteristic change. So what is the change? So this is Fe C6H5O 3 times. Okay, C6H5O, phenoxide ion, plus, okay, HCl, 3 HCl. This is the way you can write. Okay, there's another way also. There's another way of us writing of this one is there, but this is the simplest way, neutral compound like, right? So this is responsible for violet coloration. So you have to write these things, violet coloration, and then write here no characteristic change. No characteristic change. This is the way of writing in the examinations. Two compounds given, choose the reagent first, then write the same reagent, write the product, okay, and write the color change. Almost you have to write this, particularly the violet color you should write. So then only there is a meaning. So no characteristic change is a better word that you can use, better sentence that you can write here in front of it, right? Right. This is the way that you have to write. Now, propane 1-ol, propane 2-ol, right? Propane 1-ol, propane 2-ol. If this is the question, then how to write that? You have to write the structure propane 1-ol. This is propane 2-ol. Okay, propane 1-ol, propane 2-ol. Then add Lucas reagent. This is HCl plus anhydrous zinc chloride. HCl plus anhydrous zinc chloride. Okay, this reagent you should write. Then, so both will give the reaction. Remember, both will give the reaction, but not at the same condition. Okay, so you have to write here no product in room temperature. No product at room temperature. No product at room temperature. Here, white turbidity. White turbidity. Okay. After 5 minutes. After 5 minutes. Secondary alcohols are slow in reaction, then tertiary alcohols. Tertiary alcohols, immediately they give white turbidity. So the time span of getting this white turbidity itself is the characteristic change. Therefore, you may have to write this white turbidity of, you may add this also, CH3, CHCl, CH3. White turbidity of CH3, CHCl, CH3, because by HCl, By HCl, reaction with HCl, this OH is replaced by Cl, right? That is the responsibility for, this is the one responsible for white turbidity. White turbidity is the word to be used. White turbidity of CH3, Cl, CH3 after 5 minutes, after a span of time, right? So you may note in that way. So this is the way of writing in the examination, right? To get full marks, okay? Now, ethanol and propanol. Ethanol and propanol. Okay, ethanol and propanol both are alcohols. Ethanol and propanol. Okay. So ethanol gives iodoform test because it is having this skeleton. Here next to COH, there is no CH3, therefore it won't give. I don't mean that it won't react at all. Therefore, the better word to write, no characteristic change. Iodoform is not formed, right? So in the presence of I2, this will first convert into CH3, CHO plus HI. It is converted into aldehyde, right? Ethanol will give aldehyde. Okay, so that or any other two ketones are being formed otherwise. So this CH3CO again reacts with I2. As I told you, it replaces all hydrogen of this acidic hydrogen of aldehyde. This is called acidic hydrogen, one which is very next to C double bond O. C double bond O, very next to that carbon atom, this hydrogen is called acidic, and this acidic hydrogen is replaced. So I2 replaces all hydrogen, acidic hydrogen next to C double bond O. So this is the first thing that happens to the aldehyde. Then reaction with NaOH. Reaction with NaOH gives CHI3, CHI3 and sodium salt of the carboxylic acid which is there. HCO, ONA is being formed. Okay. So this is iodoform, yellow PPT. You should write yellow PPT below that, yellow PPT. For this, you just write no characteristic change. For the second compound, no characteristic change. Iodoform is not formed. Okay. So this is the way that you have to write. Now, benzaldehyde and acetone. Benzaldehyde. Benzaldehyde and acetone. Okay. Benzaldehyde and acetone. So, which is the reagent to be used? Okay, iodoform test also you can write for this. Iodoform, this will give, this won't give. If you have to write the Tollens test is given by this compound, ammonical silver nitrate, AgNH3 twice plus and OH minus. This is the way we have to represent Tollens reagent. Ammonical silver nitrate, this is AgNH3 twice plus carrying positive 1 charge and OH minus. This reacts with benzaldehyde, right? And with this Tollens reagent, you can write Tollens reagent also. Tollens reagent, no characteristic change. So product of this one is carboxylate ion. The aldehyde will become a carboxylate, COO minus. CHO becomes COO minus. And there is silver mirror. This is silver mirror. Probably you might have done in the practicals, or practicals may supposed to be taken. Silver. And then other products are NH3 and H2O. Okay. So silver mirror is obtained when Tollens reagent is being added. Okay. So this is the complete way. Try to write in the complete way so that the examiner has no chance for cutting the marks. right? Complete way if you write, there is no chance of cutting the marks in the examination, right? Okay, right. Now coming to the another thing, that naming named reactions, right? So two concepts we have taken: IUPAC naming and distinguishing test. IUPAC name may come direct question, may come for 1 mark, or indirectly it may be asked in the ABC type of questions, which carry 1 mark or 2 marks, right? And the third concept is named reactions. There are several named reactions, so I have tabulated in this way. To remember, some organization arrangement is required. Even so, we have started with organizing all the elements known in the periodic table form, right? So that we can remember. I think we also have to do in the same way for the named reactions, right? So, haloalkanes and haloarenes, the named reactions that we have understood were Schwarz reaction, Sandmeyer's reaction, Finkelstein's reaction, and Wood's reaction, right? So Wood reaction, these are the 4 reactions, right? So there is fatigue reaction and Wood fatigue reaction. These are all understood. But these are the 4 major named reactions there is a chance of asking in the examination. Then in alcohols, phenols, and ether, Kolb's reaction, Remer-Tiemann reaction, and Williamson synthesis. 3 reactions are there in the alcohol chapter. And aldehydes and ketones and carboxylic acid, Rosenmund's reduction is a method of preparation of aldehyde. Stephen's reaction, Gutterman-Koch reaction, all these are methods of preparations of aldehydes. Clemenson's reductions and Wolff-Kishner's reduction, property of aldehydes. Aldol condensation, Kenny-Jarrow's reaction, HVZ, H. Hell-Vollard-Zielinski's reaction. These are all the reactions of aldehydes, ketones, and carboxylic acid. Hoffman's bromide degradation, carbylamine reaction, and Gabriel phthalimide synthesis. So these are the reactions of amines. Of course, you all studied this. But for remembering, the tabulation will help you, right? Now we will make some drill work to understand or to recall this, right? Right. Can you able to tell me what are the reactions of haloalkanes and haloarenes? Why I am telling you this is remembering which chapter it comes. Remembering that which chapter it comes will help you to write the reactions, complete reaction, right? For that, so whenever the named reaction is given, recall from which chapter it has been taken, right? Haloalkanes and haloarenes, Finkelstein's reaction, and Schwarz reaction. These are the 2 halogen exchange methods. Finkelstein's reaction, Schwarz reaction, halogen exchange method. Sandmeyer's reaction, right? Sandmeyer's reaction, right? And Wood's reaction. Wood's reaction is a property of haloalkane. In that we have studied, right? Okay, these are the 4 reactions. So what I suggest you is, you also make a table, write or make 4 columns and write these named reactions, and then practice the same reactions which chapter that belongs to. Okay, take the blank one and again try to fill that. This exercise will help you to remember the named reactions of that particular chapter. Now quickly think of, okay, these are the reactions, right? Now can you recall the alcohols, phenols, and ethers? Alcohols, phenols, and ether, fill that. Alcohols, phenols, and ether. At least one you can able to recall. Yes, Kolb's reaction, Remer-Tiemann reaction, Williamson synthesis. Okay, So you may use different colors for a different chapter so that you can remember it more easily, right? Now, aldehydes, ketones, and carboxylic acid. So there were three or four from preparation. So Rosenmund's reduction, Stephens reaction, right? Gutterman-Koch reaction, right? These are all from the preparation. Then reduction, Rosenmund's reduction, Wolff-Kishner's reduction, right? These are all from the reduction. Then aldol condensation, Kennigerose reaction, and one from the carboxylic acid is HVZ reaction, Hell-Vollard-Zielinski's reaction, right? Then, okay. Then finally, amines. For amines, three reactions. One is Gabriel phthalimide synthesis, Hoffman's bromamide reaction, right? And then carbylamine reaction. Of course, carbylamine reaction and aldol condensation are not the name of any scientist there, but this oftenly asked thing. Therefore, I have taken here, right? Okay, so this quickly let us look into this Sandmeyer's reaction. When the Sandmeyer's reaction is being given, you should write in this way. Aryl N2X. Sandmeyer's reaction is benzene diazonium salt. Benzene diazonium salt will give chlorobenzene, bromobenzene, or cyanobenzene. So in the presence of CuCl-HCl or CuBr-HBr and CuCN-KCN. This is Sandmeyer's reaction. Okay, right? Wood's reaction is alkyl halides or aryl halides in the presence of sodium, metal in ether, dry ether, will give a hydrocarbon, right? So number of carbon atoms in an alkyl group is doubled in the product that is obtained. So this is Wood's reaction. Swartz reaction. Swartz reaction is alkyl bromides or alkyl chlorides, which are easily prepared, from which you can convert into fluoroalkanes, right? So method of Swartz reaction is to prepare fluoroalkanes. Okay, so this is an halogen exchange method. Bromine is replaced by fluorine. Your reagent is silver fluoride. Right? Finkelstein's reaction. Alkyl halide, NaI, Ri. So this is also halogen exchange method. Chlorine or bromine, chlorobromo halides, chlorobromo compounds are converted into iodo compounds in the presence of NaI in acetone, right? So this is Finkelstein's reaction, right? So coming to the reactions of alcohols, Kolb's reaction is conversion from alcohol to salicylic acid or 2-hydroxybenzoic acid. Remember, initially the starting reagent, compound and the final product. Initially, remember these things. Then slowly recall the reagents. It is a 2-3 stages process to remember, right? Identify which reaction belongs to which chapter, so that it can help. It will initiate you to write what is the starting material or the product, right? Kolb's reaction. So this is a chapter from alcohol and phenols and ethers. Therefore, one of the compounds should be either here or the product. This way you can help yourself. So phenol, it is you may recall that this is a product, this is the property of the phenol. Phenol in the presence of NaOH will give you ONA, and in the presence of CO2 plus H plus will give you salicylic acid. Conditions are there to write. So slowly you acquaint the conditions for the reaction and all those things. So stage by stage you go and remember a whole lot of time. Bremer-Tiemann reaction, phenol to salicylaldehyde. Right? Okay. What happened? Okay. So this is the way that you can able to remember. the whole lot of reactions, all reactions that you can remember, right? So how to have a practice of this, right? Okay, just a minute. Okay, so let us know your understanding. Now there is a reaction given. Okay, whatever the exercise that I have told will help you to find out which reaction is this. Can you able to? Now look at the question. Methyl bromide or bromomethane with silver fluoride will give you fluoromethane. Which compound is which reaction is this? Told you that silver fluoride is used is a halogen exchange method, Finkelstein's reaction. It is chapter 1. Finkelstein's reaction, something about fluorine. So in this way, you can connect yourself and find out the answer to this. Right. Okay. Right. Okay. Oof. Just for okay. Okay, fine. It's not working. Yes, Schwarz reaction. Now I'm coming to this. Alkyl halide and sodium alkoxide giving ether. Okay. Okay, some of you may be having good memory and can recall very easily. For some need practice. Some need practice, right? So it is a method of preparation of ether. It is a method of preparation of ether. Product is an ether. Therefore, it is a second chapter. The second chapter, which are the named reactions. So second chapter, Coles reaction, Raymer-Tayman reaction, and Williamson synthesis. Right. Therefore, it must be Williamson synthesis. Okay, you may connect it like this. Right. This is Williamson's synthesis. Now, what about this? An amide with bromine and NaOH will give you an amine. It is something about degradation, right? CO is being removed here, right? So this is Hoffman's bromamide degradation. Sorry. Okay. This is Hoffman's bromamide degradation. Hoffman's bromide degradation. Right. So it is the fourth chapter. Fourth chapter because of the amines. Amines, fourth chapter, Hoffman's bromide degradation. Right. Now finally, a phenol in the presence of sodium hydroxide gives CO2 and H plus to give salicylic acid. So this is 2-hydroxybenzoic acid. So Kolb's reaction, right? Kolb's reaction, salicylaldehyde, Raymer-Tayman reaction. Okay, there's a chance of confusion. Have a idea, correct idea, right? Kolb's reaction, right? Okay. So any other question regarding this, you can ask or you can post so that I will try to answer in the next session when I come before that, right? Because it is not connected to the Zoom meeting. Only I'm getting the chats of YouTube channel. So once I am able to see that, your queries can be addressed. I hope so. Okay, so the three concepts that I have told you, they are IUPAC naming, prefixes and suffixes, and in suffixes, which is the priority. One important thing that you can remember is whatever is from left to right, so priority increases. Prefixes, word root, then suffix. Suffix is more prior than the word root. Okay, whenever functional group is there, you have to include the functional group in the carbon-carbon chain. Therefore, word root, more than the word root, the functional group is important. So more than the chlorine, the word root is important. Okay. So ene is important more than the chloro or functional group, which are the prefixes. So the way of writing will help you to remember a lot of things, right? That is to be taken in case of IUPAC naming. And in the distinguishing test, okay, remember the seven reagents, and given two organic compounds, use one of the reagent clearly, which distinguishes, and make the practice of writing the way that is required. Okay. And named reactions. Named reactions are named reactions. You have to make a little practice, make the tabular column, and make some practice. Then to write the whole reaction, you may need a little more time. You may have to practice a little more. Of course, it is possible. Two questions will come on named reactions usually. Nowadays, the competency-based questions are asked. Therefore, we do not find more weightage for recalling such kind of questions. Named reactions are avoided, but we find that at least one question will be there in the named reaction. Therefore, it is to be taken care of. Thank you, and we'll meet you in the next session with more responses from you. And have always a paper with you, and try all these things. That's the best way that we can make use of this class. Thank you.
It's on.